Let's talk about 3D shapes today. And unfortunately, it's going to be very definition heavy. Just like we were dealing with 2D shapes, we're going to start with something that's a simple and closed. This time we're going to call it a surface though, because we're going to have these 3D areas. A simple closed surface has exactly one interior, so no snowmen that have like 3 spheres on top of each other. No holes, so we can't have donuts or bagels, and is hollow. Some common examples are a sphere, like a basketball, a pyramid, like a pyramid, a cylinder, which is kind of like a vegetable can, and a cone, like an ice cream cone. First, let's look at some special types of these simple closed surfaces called a polyhedron. And a polyhedron has polygons as faces, so things like squares and rectangles and pentagons. In polygons, we had the points and we called them vertices. We're still going to call them vertices in a polyhedron. We would classify the polygons by their sides, like a square has 4 sides. But instead of sides, we're now going to call these edges in 3D shapes. Over here to the side, I have a polyhedron. This is a polyhedron because it has polygons as its sides. It has triangles and then a square or rectangle base down here. So this is a polyhedron. The vertices are H, I, J, L, and K up at the top. Has quite a few edges. The edges are HI, IJ, JL, LH, and going up to the top, we've got HK, IK, JK, and LK. The faces, we have the quadrilateral down there at the bottom, HIJL, and then we have the triangles going around, so HIK, IJK, JLK, and LKH. Some of these polyhedrons have a special name. The first one we're going to look at is a prism. So the prism is a polyhedron, so all made up of polygons. It's got a pretty heavy definition. We have 2 faces that lie in parallel planes, and the lateral faces are parallelograms. So we've got an example here. The lateral faces are the ones going around the middle, and this one's a special one because instead of just being a parallelogram, they're actually rectangles, and I'm going to talk about that in a second. The lateral faces are the middle. The bases I have shaded are triangles. I haven't got to what it means to be right yet. I'll get there in a second, but we call this a triangular prism. The bases are triangles, and it's a prism because it has 2 bases. That's what we mean by the 2 faces that lie in the parallel planes. Over here, I've got another prism. This one, I've got my lateral faces going around, and my bases are either squares or rectangles, and we're going to call this a rectangular prism. Now, these prisms can be right or oblique. That's why I have the right here. So if all those lateral faces, the middle ones, are rectangles, then we say it is a right prism. If the lateral faces are not rectangles, then we say it is oblique. So if we take a look down here at my examples, I've got some that are oblique and some that are right. So if you look here, this guy, my first one, is right because these guys are rectangles going around. Remember, rectangles are a special type of parallelogram. So these are both prisms. In fact, we could call this one a right, and it's got 1, 2, 3, 4, 5, 6 sides. So hexagonal prism is my first shape I have here, a right hexagonal prism. My second shape is oblique because instead of rectangles, I have parallelograms. So we would call this guy oblique, and it looks like it has 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. Yep, so it would be octagonal, and and it is also a prism. So a right hexagonal prism and an oblique octagonal prism here. My math lab is not very good about naming. They'll want you to use one word for one problem or a different word. They might just be going after right, or they just might be worried about prism. When I'm going to give you a shape, I want you to use 3 names. If it's right or oblique, then the type of base it has, a hexagon or octagon. And if it's a prism, or our next shape, which is a pyramid. Pyramid's very similar to a prism, but instead of having 2 bases that are lying on these parallel planes, it's going to have an apex, this point at the top. So now it's determined, again, by this polygon, because it's a polyhedron, and a point that's not in the plane. We call the polygon the base, and the point the apex. The height of the pyramid is perpendicular. It's a perpendicular line segment from the apex to the base. This is going to be very important when we get to some of our computational sections. The height is in the middle of these pyramids. Just like with a prism, they can be right or oblique. So we say if it's right, if the height connects the apex to the center of the base. If it's anywhere other than the center, then it is oblique. So I have some examples down here. My first example is right, because it's standing kind of straight up and down. That base is a hexagon, and this is a pyramid. Again, 3 words to name a shape. My next one is oblique. If I were to connect the top of that apex down, I would not end up in the middle of my base. And I'm just going to call that rectangular. If you marked that as square, I would take it off. And it is a pyramid. One last thing we can do to these polyhedrons, we can truncate them, which basically means you chop off the top of it. We have to be able to tell if we have a prism or a pyramid, and you want to look at your sides. If I have a prism, they're going to look like those rectangles, those parallelograms. If I have a pyramid, they're not. In a pyramid, they come together at the apex point, so they should kind of be shrinking as we go up. Now, we've chopped off the apex, so we can't see it. So these guys, instead of using the word right and oblique, I'm going to use the word truncated. So I would call this a truncated. It has 6 sides, so it's a hexagonal, and this one is a prism. My other one is truncated, and it also has 6 sides, so hexagonal, and this one is a pyramid. I just have to look and see if my lateral faces look like they're going straight up and down, those 90 degrees down here, they're all going straight, then I'm in a prism. If it looks like they're getting smaller and smaller, closer and closer together as I get to the top, I'm going to be dealing with a pyramid.